Hello guys, I'm gonna be I'm doing question 2 to that paper we were doing earlier, and I'll go through it the same way I did question 1. I thought I'd screwed up my actual thing. I found out I didn't. I made a couple of mistakes. So I've just drawn some extra lines going from here to here, so that just helps me out. And I'm gonna label each. You can see these are radii. I'm gonna label each radii R. Label that R. And you can see that this angle would be 60 because the equilateral triangle bisected, so it's 30. Oh, that R is tiny. Oh well, that's okay. Now let's get something straight. What is the area of K? Pi R squared. Pi R squared. What is the circumference of K? 2 pi R. That should be right. What is the area of... Now, we don't know what the area of J is. But let's do some trigonometry to do this, to work this out. So, guys, you gotta realize... What you need to realize is... what is the outer length of this triangle? And what is this length, by the way? So, what you'd do is you'd look at it, and you can see that there is a right angle right there. If you can't see it, I'll just point it out for you guys. Right angle right there. And you get them everywhere. You get them there. But I find this one easy to look at. I doubt you guys do. So we have R over here, and what you know is this angle is 1/6 of a circle, so it must be 60 degrees. And you know that we want to find what is this length. First of all, we want to find this length as well, but we also want to find this length. And if you find this length, it'll give us like an irrational number, which we don't know how to express at the moment. But if we find this length and then find out this length, we will get that irrational number in the form of a square root, which we can express mathematically. So let's start off with this. This is R. This is the hypotenuse of a right angle triangle. This is the adjacent, because this is the angle 60. We could have used this angle, we're using this one. So we know that cos 60 is, if this was a full triangle, you know that this length is like half of this length. So you know that this length is 2R. This length here. Not this whole length, just this length. It's 2R. We're going to keep that in mind. Now we can work out this length. Pythagoras. This squared minus this squared will give us this squared. So we can factorize the R out of it. We know that 1R plus 1R, I'll do 1R squared, 1R all squared. And because this is a measurement, we can take it in terms of R and cube R cubic units. So 1 plus x, 1 squared plus x squared equals 2 squared, because we know that length is 2. Then we can cancel it out to 1 plus x squared is equal to 4. X squared must equal 3, so therefore x is equal to the square root of 3. You remember that this measurement is equal to the square root of 3. So therefore, what is the perimeter of J? Square root of 3, 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 square root of 3. The perimeter of J is the 6 times the square root. I really gotta get a square root button on my keyboard. Square root of 3. So that is the perimeter of J. This is the circumference of K. And this is the area of K. But we need to find the area of J. What is the formula for area of a triangle? It is... let me draw some triangles on here. We all know it's half base times height or something like that. We're going to work out the height, the base, and divide it by 2. What's the height of this triangle? You can obviously see that the height is going to be this length, which is equal to this length, which we discussed as being equal to 2, and this length, which is equal to 1, so it's 3 times the base divided by 2. 3 times the base divided by 2. So let's work this out. What's the base again? The base is 2 the square root of 3, 2 the square root of 3 times the height, which is 3r. And remember, we ought to start using stuff so it's going to be 2r square root of 3 times 3r, which cancels off into okay, it's going to be halved as well, so you're going to get rid of that 2. And these, this r can become an r squared. And remember, that's not a division sign, that's a square root sign. So it's going to just be 3 r squared square root of 3 is the area of triangle. Now, let's put it all together. What is the area of K? Pi r squared. No, I really got to improve my font size. Let's go up a notch. Yeah, now we're talking. Pi r squared. That's area of K. That means some circumference of K, which is 2 pi r. And then we're going to need the area of J, which was 3r squared, the square root of 3, and we know that the perimeter was 6 the square root of 3. Actually, it was 6r the square root of 3. I'm going to actually add that r in because we might need it later. I've been ignoring r because I've been treating it in terms of 1, but it has to be 6r. Okay, now we obviously know that these two must be equal because from this equation, because it asks us to prove that. But we can't assume that, so we're going to treat them differently for the time being, guys. I'm sorry that you know the answer, but I can't pretend it's real yet. Okay, let's just do some cancellation. How can we cancel this equation? We can get rid of the r squared straight off. R squared. So we get... so this cancels out into pi 3 square root 3. That is what it cancels out into. This one over here, let's see what it cancels out into. Obviously it's going to be the same because that's the answer. So let's see. 2 pi r, 6r, so basically the 6 and the 2, that's going to cancel out into 3. Cancel out into 3. That one single r is going to cancel out. I know I've used capitals, so it's not really perfect. And that is going to equal pi over 3 square root of 3. Put that line in there. So yeah, basically guys, this equation over here to do with actually this one, no, this one cancels out into pi divided by 3 root 3. This one cancels out into pi root 3. And if you are terribly weak in mathematics, I am pleased to tell you that these two are equal. Can you see that, guys? They're equal. Yeah, so that's how I proved it in the exam. I made a mistake while going through this earlier, because in my previous video, I accidentally thought that this length was 2, because I did the sign wrong, because I forgot it. This is the height and stuff. Yeah, I always get confused with pi. Guys, by the way, when you're not doing height, when you're just doing when you're doing the two non-hypotenuse sides of an angle, and you got a sine 30 or cos 60, or Pythagoras or anything, you got to remember you're normally going to get, if it's 1, 1, it's going to be a square root of 2, and if it's a 1, 2, you're going to get a square root of 5. I was surprised that this was a 1, 2, and I got a square root of 3 in my, because I actually thought it was a 1, 2 square root of 5, but when I checked back my answers, I found I'd done a 1, 2 square root of 3, and I was very confused about that, and I realized I was subtracting because the 2 is the hypotenuse, not the adjacent, as you'd say if it was 30. So that is how I showed you guys. I did look at my answers, but I'll just go through how I explained it to the examiner. Let the radius of the circle be r. Lines can be drawn from the center. Oh, I used the US spelling. Okay, yeah, guys, I used the US spelling. I got shouted at. Lines can be drawn from the center of the circle to the corners and tangents. If triangle ABC was drawn, yeah, they done something like, I think I don't know if I put the ABC in, but I said if triangle ABC was drawn, you would get ACB was as 60 degrees, as it is 1/6 of the circle. I'm talking about some stuff, so that I didn't put on my diagram, but cos 60 always equals a half, tick. So length AC must be twice as much as r. You could use Pythagoras' theorem to work out the remaining side, which is the square root of 3r. We can now use the hypotenuse of this triangle to find the height of the triangle. I got circled that because I didn't say which triangle is 3r. The length of one side must be 2r pi from the triangle ABC. The area of the circle is pi squared. The area of the triangle is 3r times 2r to the power of 2r square root of 3 divided by 2. This can be expressed, I should have said the ratio, as pi r squared divided by 6r squared square root of 3 divided by 2, which is equal to pi divided by 3 times the square root of 3. The perimeter of the triangle is 2r square root of 3 times 3, which is equal to 6r over divided by 3. The circumference of the circle is 2 pi r. Then I just drew it again, equation, and then it cancels out to pi over 3 square root of 3, and I said they are both equal to 3 divided by 3 times the square root of 3. So guys, that is my solution to the second question, and I'll just go through their solution as well, because I always do that. You guys are free to leave now if you want to, but I'm going to go through this anyway. It's page 29 again. I'm going to be looking at 29 a lot. Okay. Question 2. Okay. Yep, so they said the sides of an equilateral triangle are 3 tangents of circle, yep. Let the radius be r, hence the circumference is 2 pi r and the area is pi r squared. All the angles in an equal triangle are 60 degrees from center of the vertex. Note that the interior, since the tangent is perpendicular, the shaded triangle is right angled to the line. These and hence, so that is half an equal, yeah, let's skip a bit. Hence, the shaded area of a triangle has 60-90 degrees, so it's half an equilateral triangle. Therefore, the side of the ratio is 1 square root of 3 and 2. Yeah, guys, remember the height of a equilateral triangle is the square root of 3. But one side has length r, so the other sides have 3 square root of 3r and 2r. And then for the perimeter, has length 6 times square root of 3r, so that, yep. And then it'll cancel down to pi divided by 3 square root of 3. And they did the same for the area. Pi r squared divided by 3 square root of 3r squared. Cancel down. It follows that, yep, as required. Good. That is the question 2 sorted. I hope you got the same answer. I screwed it up a few minutes ago. I looked at my question carefully. I worked it out where I went wrong. But in the real thing, I did it correctly. I didn't screw up. So guys, this is how you do this question. And I hope you got this. And yeah, tell your friends. But remember guys, this is a tough series I'm doing. So make sure you're the most elite ready for this.